Hi everyone, this is my voiceover of the series that I originally recorded for my overseas audience, and now, since there is some interest from my Silicon Valley community, I decided to quickly translate it. Today is the 7th episode on how to build MES, Manufacturing Execution System, or CRM, Customer Relationship Management, software from scratch in LabVIEW. All episodes are organized in order inside the playlist, which is named in the same name. The link to that playlist is in the description to this video. In this episode, we will continue improving our state machine and connecting new buttons using functions from the Database Connectivity Toolkit. Sometimes I feel like every new button in LabVIEW is just another way of saying, surprise, you're a full stack engineer now. At this point, the project already includes a new program, the Encrypt function, to protect our data in the database, and 3 new sub-VIs that we'll use today: sub-VI-DB delete record, sub-VI-DB read instruction, and sub-VI-DB save instruction. I already copied the file VI-DB provider 4, the one we worked on in the previous episode, renamed it to DB provider 5, this is the file we'll work with now, added to the project, and saved everything. Let's open our new VI and go to the block diagram, the variables case. Let's take all variables from here. We will need all of them today. Going back to wait for event and moving to the event case, save DB table. Now let's create a new event. Add event case, type DB table, choose mouse up. Here we reduce the view, we only keep chords. We place them below the error wire. DB table goes into this event. We create a constant as usual, connect enum, wait for event, and pass the path to our database through sub-VI-DB path. If you watched the previous episode, you know exactly where this connection comes from and why it's here. In this DB table mouse up event, we will color rows and columns in the table. Their background color will change depending on mouse interaction. Now we need to choose the functions involved in this event. We create an invoke node from DB table create invoke node, point to row column. Place it on the error wire and connect chords to point. Next, from DB table, we create a property node. Create property node value. Connect to the error wire, add index array function. From array, choose index array. Value from DB table goes to the array input on index array. It automatically expands to a 2D array. Honestly, half of LabVIEW development feels like wiring Christmas lights, except the lights are 2D arrays. Then we add a constant on the index column, leaving it at 0. From cluster functions, let's add unbundle by name function, connected to cell position. It automatically selects row, which is exactly what we need. We connect this row to the index array function on the disabled index row input. Now let's add a case structure. From structures, select case structure, expand it. Connect the error wire from DB table property node to the case structure. On true, we simply pass the error wire through. Next, from comparison functions, we place empty string path function. Connect it to the case selector and connect element output from index array function. And here we also need to connect index ID. Empty string path function is the LabVIEW version of "Did you forget to fill out that field?" Something every UI on earth keeps reminding us about. Next, let's switch to false. On false, we create a property node from DB table, active cell. Select active cell. Move it slightly to the right. Just give me a second here while I'm fixing it. Okay. Expanded, it automatically adds cell background color. Perfect. That's what we need, and we actually need 3 sets of each. Here we need to make changes. Select property, active cell, choose active cell. Expanded, add cell background color. Next, add a third one the same way. Then change all to right and create constants. Create constant, again create constant, and one more time create constant. Connect all constants. Now the first active cell constant will be -2, -2. Let's move things around a bit. The second active cell constant will be -1 and -2. I'll explain what it means later. Let's move all elements into place. The first background color we set to light gray. The second color we leave as is for now. The third background color we set to dark gray. Now this third property works differently from the first two. What I mean by that is we need to change background color to control. Change to control, and this becomes a color box. It will appear on the front panel and we will see it now. But first, let's rename it to header color because it will be the color for our column headers. User interface colors are fun until someone says, let's use dark mode, and suddenly half the palette becomes invisible. Now in the third active cell, let's connect. Oh, actually, let's remove these constants, we don't need them. Now from cluster functions, let's add bundle function, connect its first element to row. For the second element, we need a constant -2, but it won't be created easily, so we copy it from the previous active cell constant and reuse it. Connect it to bundle, then connect bundle to active cell property. Everything false is connected. Let's save and switch back to the front panel. Here's our header color box. We switch tabs using visible items tabs and move header color here under sort num. Choose the color we want for column headers. Done. So what exactly did we just do? Let's go through it step by step. Based on the number of this row, we take the value from 0 column index ID using the index array function. And if this cell is empty index ID, then nothing happens. But if there is something inside the cell, then the function of coloring our table in different colors is executed. In this function, we use the property node, active cell, and cell background color. When we expand this function sequentially, they execute in order. If we open context help and hover the cursor over active cell, we can click on detailed help and we'll see what these numbers mean. The ones we set in the constant. -2 means selects all rows and columns, including column headers. So here we first reset the entire table to our standard color, light gray. For this, the symbols -2 used. The first -2 is for the row and the second -2 for the columns. Then we paint only the headers, column headers. For that, -1 is used for the row and -2 for the columns. Also in context help right here, there is a -1, -2, selects the headers of all columns. So we close the context help. And the next action is that we color with dark gray the row that we clicked on, that we selected with the mouse. And now let's see how this works. I start the program, I choose the table, I press DB refresh table, and all values appear here. So now I want to, for example, I select any row. Immediately in one motion, the column headers are recolored into the color that I set in header color. But the first action is that the entire table is recolored background color light gray, and the row that I selected where I placed the mouse is colored dark gray. That's how it works. And here in index ID, it shows that this is the 7th index ID, number 7, that I selected. Let's press power, exit from here, and move on. Next, we move to the event case for deleting a record from the table we are currently in. If you're interested how to delete a record from all tables, let me know in the comments. We can look into it in upcoming episodes. So here we have the delete button, and here we have a boolean delete record from DB. Create a new event, add event case, choose delete record from DB, move elements upward, bring delete record boolean in, connect enum wait for event, and connect the database path as usual. We already have sub-vi db delete record, just drag it into the diagram. And now let's reopen it and see how it works. So here we have the standard procedure for opening the database. We already went through it earlier. Then we select the first column using the function from connectivity, db tools list columns. I can turn on context help to make it clearer. Yes, here's the dbTools list columns function. And we create an SQL command in order to send it to the delete function. Here is the delete function, dbTools delete data. And here we have the SQL command where, meaning this is the operator that defines in which column where SQL command where exactly matching the value of the index ID that we selected. You know, the funny part is, while text-based programmers debate curly braces, we just drop a block and wire it. LabVIEW feels like cheating, but in a good way. Now, we'll connect everything, assign the dialogues, and check how this works. And now from dbTable list, we want to add a property node here. Create property node value. We place it here, move everything a bit. First, we also need to wrap this all into a case structure. We add a case structure like this, and it must be on case false. So right away, we do make this case false. And then we connect everything. This goes here. dbTable list and delete the record from DB are connected to the error wire. Now the value from dbTable list needs to be connected to the sub-VI. We also connect to the sub-VI our database path. This comes from another sub-VI DB path. We did this the last time, as I already mentioned. So here we find the DB instruction connection. Connected. Every time I create a new sub-VI, I imagine Python and C++ developers whispering, "Wait, you can just see your logic?" Okay, here for the case selector, we also need from comparison functions, the function empty string path. And here we also need a local variable from index ID. To do that, we can go to the front panel and do create local variable. We place it here, switch to change to read, and connect it to the string path input of the function and also to the sub-VI itself, like that. That's it here. On false, everything is done, but now we also need to work on the true case. Oh, before that, dbTable list will no longer be needed here, so I will move it to where it belongs, to db refresh list, event case. We built it in the previous episodes. I place it here so it won't be lost on the block diagram. This is where it belongs. Now we return to our case. These are all the event cases we have created throughout all the episodes. We select the one we need now, delete record from DB, and we go to true. Here we connect the error wire. We add a dialog, one button dialog, and in the same message we create a constant and write nothing to delete, like that. We save it. LabVIEW wiring a database connection visually is like magic. Meanwhile, text coders are somewhere debugging a semicolon they forgot in 2019, huh? And now, what did we do here? We'll have two dialogues. In one of them, the program checks whether index ID exists, and if it doesn't, it reminds the operator there is nothing to delete. And the second dialog is inside the sub-VI. You've seen it already. This dialog is two-button dialog, and it says, "Attention, record will be deleted forever." And here the operator can change their mind and press cancel. Now let's demonstrate it. Running the program now, and for example, yes, I already selected this row here. It is already highlighted. When I delete it, I get the message, "Attention, record will be deleted forever." And I can choose OK or cancel. I press OK, for example, and then I press refresh table. And my 7th index, everything that was under index ID number 7, both rows, got deleted. There were two rows here. So this deletes from one table. And if I click, for example, somewhere in a row where there is no data and then press delete, I get a pop-up window that says nothing to delete. I just love how in LabVIEW delete record is literally a block. In text code, it looks like a spell from Harry Potter, and it breaks just as easily. Okay, power off. Moving on. Next, let's solve the following puzzle. We have been using sub-VI DB path in which our database instruction is unchangeable. Here it is. This sub-VI is currently initialized, meaning the database instruction is unchangeable. It is strict. But we want to be able to change this instruction depending on where the database is located, what the name of the database is, and what the database password is. For that, we need to create a window where we'll include all this and the Save button. For that, I go to the Settings tab and copy and paste. I already have it prepared, DB instruction string and the Save button. Now we find them on the block diagram. Here we have Save DB instruction and DB instruction string. We go to the event structure and let's create a new event. After the case delete record, let's create Save DB instruction case. Add event case, find it in filter event sources, Save DB okay. We keep source, place the boolean Save DB instruction with the same name as the event. As usual, we add the constant wait for event and connect the database path. Now we already have the prepared LabVIEW DB save instruction, so I simply drag it from the project onto the block diagram and place it on the error wire. And let's reopen it and take a look at how it works. So here you see application path, VI or executable installation directory. Application path brings us to the folder where our program is located on the computer. Using the function build path, we create or rather designate a new path into a subfolder called config. In this new folder, there will be a file named config.ini. Right here, after the case structure, you see config.ini. In this file, we'll save the encrypted instruction, meaning that if someone wants to know where the database is located and what the database password is, they will not be able to do that. This way, the path and access to our database are protected, encrypted. Encrypting a string in LabVIEW, just drag, drop, done. Encrypting in text code, 5 libraries, 3 Stack Overflow posts, and emotional damage. So the new path is now created. And after that, we must check whether the folder exists or not. If not, then we create it. Then we access our file config.ini. Yes, here it is. We created. We already talked about how it works in previous episodes. Here we have the functions check if file or folder exists and then create folder if it doesn't exist. Then we access our file config.ini here on build path. And if this file is not there, it will be created automatically. Why? Because here we have the function open config data. And here we immediately have the input create file if necessary. It is set to true. The true constant means the file will be created automatically by default if it's not there. Then the encryption of our string DB instruction in happens. Here you can see it. And its encoding is performed by the program Blowfish encryption in. And here you can see the detailed info about this program. Anyone interested can find its description here. Then we wrote into the section in the write key function. Here in the section input, we wrote DB instruction string and the key for DB instruction. Here is the input key. It is named DB instr. The next step is to check how we wrote it. In order to check it, we need to open it. To open it, we must read it using the function read key. Here it is. And then decode it using Blowfish encryption out, like that. And our secret key for encoding and decoding with Blowfish encryption in and Blowfish encryption out, our secret key is right here, 123. 123 is just an example, of course, but usually this is a complex set of characters and must be identical and stored in the source code, not accessible to the user. At the input and the output, before encryption and after decryption, the database path must remain unchanged, meaning that DB instruction in to the left of the case structure at the input here must be equal to DB instruction out, what we see at the output after the case structure, after all operations. That's how it all works. And then we can close it, connect the sub-VI. It is already on the block diagram. What we need to do now is connect the application path here. Here we'll have DB instruction string on the left of the sub-VI and at the DB instruction string input. And now from it, we need to create a local variable and place it on the right. This will be DB instruction out, like that. Save it. Also, part of this code from sub-VI DB save instruction, the part you just saw, we'll use for reading the instruction when the program starts. Let's open the initialize case and remove sub-VI DB path and place sub-VI DB read instruction here. Return all connections here. Connect everything just like in the previous case, but here we also add DB instruction string. I can take it from the front panel, so I don't have to click far, create local variable and place it here, like that. Save it. And we also need to check how it works. I said earlier that part of the code from save DB instruction sub-VI is used here. Yes, indeed, as you can see, here is the part of the code we just examined. Using the key 123, we decode our string and get the database instruction. Now let's check how it all works. So for this, what we'll do, we'll remove tabs, run the program, and I already prepared the path, DB instruction string. I paste it here, like that, and now I save it, save DB instruction. I get the message, save DB instruction, I say OK. And after that, a file must have been created in my folder. Yes, here it is, the new folder config. I go inside, I see the file config.ini, the encrypted path to our database. Here's how it looks. And this way our path to the database is protected and no one will be able to open it, close it, or get access to it without us. That's how encryption, decryption, and saving the database path works. So, now the program starts on a random tab that I selected earlier, and I want to make it start when I launch it from the home position. For that, I go to the timeout, radio buttons, event case, and from radio buttons main, I create a local variable, and from tab main, I also create a local variable. Yes, like that. And I add them to the variables case, place them here, and from them I create constants. And both constants I set to home. And now when we run the program, everything should work and it should immediately start on the home button. Let's see. Yes, it immediately switched. It always starts from home. And then we can continue using all the other buttons and functions that we connected in previous episodes and in this episode. Honestly, this is another moment when text-based coders look at LabVIEW and think, wait, that's it? That's the entire logic? Well, that's it for today. And I just want to remind you that the source code of our program from this episode can be found below in the description. In the next episode, we'll continue improving the databases and we'll look at it from a different angle, add new capabilities for managing tables and databases, new functions, administrative permissions, login passwords, and so on. Thank you for joining LaPlanta Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.